So the final exam review packet, starting with question 482. Given that f of x is how that's read is equal to x divided by 3 plus 11, evaluate the following. So part A is saying f of negative 12. So keep in mind that that's coming from a standpoint of f of x. So this x and this negative 12 are in the same spot in that function notation. So even though it's not directly telling you, it is telling you that x is equal to negative 12. So what that means when you have to evaluate the following is wherever you see an x in the equation, plug in negative 12. So this is going to be negative 12 over 3, and that plus 11 is going to come down. So now I need to evaluate this like the directions say by using my PEMDAS rules. I have division and addition. I have to do the division part first. So I'm going to do negative 12 divided by 3, which is negative 4. The plus 11 comes down, and the negative 4 plus 11 is 7. So my final answer for part A is 7. Now part B is a little bit different. It's telling me that f of x is equal to negative 12. Notice that it is still negative 12, but it's in a different spot. It's telling you the whole f of x right here on the left side of the function is negative 12. So that's where that negative 12 is going to get plugged in, not for x. So I'm going to write negative 12 in place of f of x, and that x over 3 plus 11 from the function is just going to come down. So a big hint for part B that you're not plugging negative 12 in for x is because it's telling you to determine the value of x. If you have to figure out what x is, you're not going to be plugging negative 12 in for x. So that's just another hint to tell you that negative 12 goes in place of that f of x. So now I do have to continue solving this to get x by itself. If you're trying to solve for x, getting x by itself means I have to get rid of that 11 and that 3. So you get rid of what's being added or subtracted first, which means I'm going to subtract 11 from both sides to start. So negative 12 minus 11 is a negative 23, and that's equal to x over 3. So you're still trying to get x by itself because it's not quite there yet. You have to get rid of that divided by 3 by multiplying both sides by 3. So 3 times negative 23 is a negative 69, and you are equal to x all by itself. You've just solved for x. All right, moving on to 483, using that same function notation, but now this time I don't have an equation to plug into. I have a table to refer to. But I'm going to use those same concepts for part A, just like A in the last question. F of x falls in line with that f of 10. X and 10 are in the same spot, so it's just telling me to look at where x is 10. So I go to my x row and slide myself on over to find where x is 10. And when x is 10, my f of x value is 50. So f of 10, when x is 10, is equal to 50. Now using the same concept as we just did for part B in the last problem, part B for this one is saying if f of x, that whole thing, is equal to 10, then x is equal to what? I'm going to go to my f of x row, slide it over until I find where f of x is 10, and see that the corresponding x value when f of x is 10 is 2. All right, 484. It says determine the end behavior of the following power function. So this is coming from the week 14 notes that we just finished up. So what you need to know about end behavior, first of all, is the term that you're supposed to refer to determine what your end behavior is. So I'm going to write a little note off to the side about figuring out your end behavior. You have to refer to the term with the highest exponent. So the highest exponent determines your end behavior. So the end behavior of a graph is just what the graph is doing on the left side and the far right side of the graph. So you have 4 possibilities. It could either be an up-up, where the left and right ends are both going up, a down-down, where the left and right ends are both going down. It could be a down-up, where your left end is going down and your right side is going up, or vice versa, an up-down, where your left side is going up and your right side is going down. Now, what you could do for this, for all 3 parts of this question, is graph all 3 of them in your calculator and see what the ends are doing. The other way that we learned in class depends on your exponents and your coefficient, or in other words, the number in front of your variable. So if you have an even exponent, it's either going to be up, up, or down, down. Their ends are going to be going in the same direction when you have an even exponent. If you have an odd exponent, they're going to be going in opposite directions. Think of it as O for odd matches up with O for opposite directions. It's going to be either down up or up down. If you have a positive coefficient, the right side is going to be going up, so that would make it a down up. Then if you have a negative exponent, the right side is going to be going down, making your overall function an up down. So I'm going to use those rules that we just talked about to go over each one of these parts. So part A has only one term, so I know that that has to be the highest exponent because it's, again, only one term. So my exponent is 8 and it is even. That tells me it's going to be the same ending direction, so either up, up, or down, down. And it's all dependent on this positive 6. The positive 6 tells me that my ends are going to be going up on the left and the right. So this is an up, up function. Part B has 3 terms. I have to find the exponent that's the highest, and that's going to be a 6. That 6 is also even, so it's going to be either an up, up, or a down, down. And again, that depends on your coefficient. Because the coefficient is negative, it's going to be a down on the left and a down on the right. So it's a down, down end behavior. Part C a little bit different, but I still go to that highest exponent. The highest exponent is 9, which is odd. And because it's odd, it's going to be opposite ending, so either down, up, or up, down. And it's all depending on this positive coefficient. Because it's a positive coefficient, it's going to be ending up. So this one's going to be down to start and up on the right. All right, moving right along, 485. So state whether or not the following are functions and explain your answer. Make sure you do not skip out on that explain. It counts as points. So for part A, I have a graph. To figure out if a graph is a function, you have to do something called the vertical line test. The vertical line test tells you whether or not it's a function based on how many times it touches the graph. If your vertical line only touches the graph once, it is a function. If it touches the graph more than once, like this one touches twice, it is not a function. It could touch 3 times, 4 times. That would still mean it's not a function. It is only a function if it touches once. So my answer is not a function, and I'm going to say because it fails the vertical line test. You could also say because the vertical line touches twice. That's almost a better answer. Okay, but definitely not a function because it either touches twice or because it fails the vertical line test. I'm going to go over here to my table. It's a little bit different, but it's all dependent on your input or your x values, and you have to look to see if they are repeating or not. So my x values are 5, 2, and 0. None of those numbers repeat, so that tells me that this is a function. Simply because x does not repeat. So x values do not repeat. Okay, so let's say in that x column I had a 5, and then that 2 was also a 5, and I had a 0. Because there's 2 5s in there in this hypothetical situation, that one would not be a function because the x value repeats. But since I have 3 different numbers, 5, 2, 0, in this example, it is a function because the x values do not repeat. Now, y values can't repeat. Doesn't matter. If you have repeating y values, it doesn't change the answer at all. You are only referring to x. Moving on to 486. So 486 says, write an equation using function notation that represents the following. You currently have $475 in a bank account that pays no interest. So I'm starting with that much money. You then earn $150 at work each week. So that number is going to change depending on the number of weeks we are talking about. It says write a formula for the balance B in dollars in the account after T weeks. So we're going to talk about using that function notation at the end. For now, I just want to write out the numbers and this situation that we've got going on. So we're starting with $475 in the account, and then we are earning money. Earning is adding money to that already $475 that we have. We are earning $150. Now that $150 is happening each weeks. So let's say we were working for 7 weeks. We would be earning $150 for 7 weeks at a time. So I have to then multiply the 150 by the amount of weeks we have been adding this money to the account. So that T is going to be multiplied to the 150. And that's the overall expression. Now I need to add that function notation. So T represents the number of weeks and B is the balance. This equation represents the balance in the account. So B is going to be equal to all of that, but using that function notation, B is a function of the amount of weeks because it changes depending on how many weeks we have been adding this weekly work paycheck. So it's going to be B, the balance of T, of the amount of weeks, is equal to 475 plus 150T. Now part B says use this formula to determine how long it will take to have $1,000 in your account if you don't spend any money. So we're just saving money at this point. Okay, but right here it's asking me to determine how long. That's essentially just asking me to find T, because T is how long we've been putting money in this account. But I have to do something with this 1,000. The $1,000 is not going to get plugged in for T because T represents weeks. This is not 1,000 weeks. I have to plug in that 1,000 for the balance of T. So, of the amount of time, I should say. So that $1,000 is going to get plugged in for balance, and the rest of the equation is just going to come down, and I'm going to now use that equation to solve for T like I was told to. So you still get rid of what's being added or subtracted first. I'm going to subtract that 475 from both sides, and it'll end up canceling out on the right side. And on the left side, 1,000 minus 475 is 525. That's going to be equal to 150T. T is still not alone, but we are almost there. It's being multiplied to 150. So to get rid of 150, I have to divide by 150 on both sides. So 525 divided by 150 is 3.5, and that's going to be equal to T because those 150s canceled. So my answer is going to be 3.5 weeks it takes for the balance to be $1,000. Right, 487. So Samantha is driving her brand new car around. Her distance from home in miles is given as a function of the time in minutes she has been driving. This function is represented by the graph below. So before you even start reading into the question, make sure you look at your axes and understand what the graph is actually telling you. As the graph is going further to the right, the amount of minutes is increasing. As the graph is going up, the miles from home is increasing. If the amount of miles that I am from home is going up, that means I'm driving away from home as the graph is going up. So for this part right here where the graph is increasing, we are getting further from home. Then over here where the graph starts going down, the number of miles from home is getting smaller, meaning you're driving towards your house. So even just taking that couple of minutes to interpret the graph, I've actually already answered part B. So I'm going to do that one first. It says describe the difference in what Samantha is doing when the graph is increasing versus decreasing. So we'll start with increasing just like we did over here. When I traced it as it was going up, again, the number of miles from home was increasing or going up, meaning that you're driving, or she is driving, away from home. So as the graph is increasing, she's driving away from home. Then when we got over here to the decreasing part of the graph, the number of miles from home was getting smaller. So if the number of miles away from home is decreasing, that means I am driving home or getting closer to home. Again, it just came from interpreting what the axes were saying and what was going on in the graph. Now going back up to part A, it says describe what might be happening between 35 and 50 minutes. So 35 is halfway between 30 and 40 here, and 50 minutes. So I'm looking in this span right here. If I go up to where the graph actually is, it's a flat line. So again, know your axes. That does not mean she's driving on flat land. If you look, 15 minutes is going by between 35 and 50 minute mark. But over here, she's staying at 6 miles from home that whole 15 minutes. So what it's telling me between 35 and 50 minutes is simply that she is not moving. She is maybe getting gas, she stopped for food, she's taking a nap, she's making a phone call, whatever she's doing, her car is not in motion. She has stopped at a distance of 6 miles from her home. Based on this graph, because after that amount of time she starts driving back home, maybe she reached her destination, she stopped at the store, whatever it may be, you can just say she's not moving, or you can have some fun with it and get creative with the answer. 488, also something that we just did in the week 14 notes, so hopefully it's fresh in our minds. It says, describe the transformations that occur in each of the following functions. So there's two different ways to do these problems as well. One of them is to just graph them and see how they changed, and the other one is to follow the rules. So I'm going to write the rules off to the side that hopefully we remember from the week 14 notes. Okay, so first one is whether it's outside or inside the parentheses. I'm just going to use these for parentheses. So if it's outside the parentheses, what you need to know is that it is a vertical change, meaning it's shifting up or down, and that it is true to what we would think it is. And again, we'll talk about it more in detail when we do the examples. But then you could also have a number inside of the parentheses that would make it a horizontal change, so left or right, and it is the opposite of what you would think. Okay, so keeping those rules in the back of our minds for now, I'm going to go over here and talk about the way to graph these. So these are all of these functions, a, b, and c, are stemming from an original function that was y is equal to x squared. That is your standard parent function parabola. That is kind of like the basis of what these are transforming from. So if I want to use the graphing method, which I'll go over first for part A, I would just sketch a quick little graph of what y equals x squared looks like. So when you're doing this, you want to plug this into your y1, that original y equals x squared function. And then you want to plug this next equation into your y2 so you can compare the two and have them graphed at the same time. So what I just graphed, that simple parabola, is the y1 equals x squared. When you graph what I boxed in red, y2 is equal to x squared plus 3, it ends up being up here, specifically up 3 values. So this one is shifting up 3. And that's all there really is to it. If you prefer to not graph it and use the rules instead, here's how you would go about doing that. So this plus 3 technically is outside of the parentheses. There are no parentheses there, which means it's on the outside of them because there's nothing to be inside of them when there aren't any to begin with. So this plus 3 is on the outside of the parentheses, meaning that it's a vertical change, so up or down, and it's true to what you would think it would be. So when I see plus 3, I think going upwards in a positive direction, so that would be up 3 because it's true to what it says. All right, trying out part B. It's the same function, but now I have parentheses in it. So I'm still, if I'm trying this graphing method, or if I prefer the graphing method, I'm going to start with that y1 equals x squared, which looks like this. And then I'm going to graph this one with the parentheses typed in. X plus 3 in parentheses squared is going to get typed into my y2. And when I look at what that looks like on the graph, it's somewhere over here. And again, these are just sketches. They're not perfect. Okay, but it's shifted to the left 3 units. So that would be the way that I would do it using the graphing method. If I want to use my rules that I wrote over here on the left side of the margin, I look at this plus 3, and I notice it's inside of the parentheses. If it's inside the parentheses, that means it's a horizontal change, so left or right, and it's the opposite of what you would think. So when I see a plus 3, I think it's moving over to the right because that's the positive direction. But it's the opposite of what I would think because it's inside of the parentheses, telling me that it's going to move on over to the left. And this last one, using the graphing method, I'm just going to go ahead and graph that original parent function to start. And again, these are just sketches, so they're not perfect. And then I'm going to plug this function that's given for part C into the y2 so I can see them both at the same time. So when that gets graphed, it's somewhere down here. So there's two different numbers or two different transformations for this one. You'll notice it moved a little bit to the right. Specifically, it went right 3. And then it also moved down, so it went down 3. Two different transformations. All right, now using what I know about the rules instead, if you don't like that graphing method, I look at this one first. Doesn't matter which one you look at first. I'm just going to check out this one first, going left to right. And it's a -3, but it's on the inside of the parentheses. So if it's on the inside, that is a horizontal change, so left or right, and it's the opposite of what you'd think. When I see a -3, I think it's moving over to the left, but the opposite would be to the right. Okay, then I have this other -3 on the outside of the parentheses. So the fact that it's on the outside of the parentheses tells me that it's going to be a vertical change, so either up or down, and it is true to what you would think it would be. So that -3, I think a -3 going down, so that would be a down 3 since it's on the outside of the parentheses. Okay. So you do not have to do both methods. I just wanted to go over both methods with you again so you can pick which one you prefer. If the rules are easier to remember or you would rather just plug it in your calculator, either method is perfectly fine. All right, 489, getting into factoring. So the different types of factoring we've looked at in this class are GCF, DOPS, trinomial easy, trinomial AC, and grouping. And for the most part, they depend on how many terms you have, but you always have to check to see if they have a GCF first. So when I look at A, I look at 6x squared minus 5x minus 4. All three of those terms do not have a common factor that can be taken out. So from that point on, I'm going to count the terms to determine what type of factoring to use. Because it has 3 terms, it's definitely going to be a trinomial. You need to figure out whether it's an easy trinomial or an AC trinomial. So this one is going to be AC because of this number in front of the x squared. Easy only works when the number in front of the x squared is 1. So I'm going to start doing the AC method. And just so you all know, any trinomial can be factored with the AC method, whether it's got the 1 in front of the x squared or not. If it has 3 terms, you can jump straight to trinomial AC every time if you prefer to only know one method. Trinomial easy is just a shortcut that works only when the coefficient of x squared is 1. So again, I'm going to go ahead and try this AC method to start, which, AC gives me the hint of how to start it. I take my A, which is 6, and multiply it to my C, which is -4, and that gets me -24. So I'm going to go ahead and list my factors of 24 to start, just ignoring that the fact that it's a -24 for now. Here are all of my factors of +24. Now I know to multiply to a -24, I need to have a positive and a negative, or a negative and a positive. It doesn't matter which order, but my goal is to add to this number right here in the middle, which for this one is a -5. So the pair that's going to work to add to the -5 is a +3 and a -8. So once I pick that pair, I'm ready to do my setup. Your setup for any trinomial AC is going to be to bring down the first term, split up that middle term into the 2 numbers you just figured out, add together to get that number. So I'm going to write plus 3x minus 8x coming from over here with the pair of factors that I picked. Now also keep in mind, I wrote plus 3x minus 8x. The order of those 2 numbers does not matter. I could have written minus 8x plus 3x. That's perfect as well. And then that -4 at the end is going to come down. So your setup is that the first and last terms come down and the middle term gets split up. And I know it sounds kind of weird to make this have more terms than it started with, but the whole purpose of that is so that you have 4 terms and you can go ahead and use the grouping method. Anytime you have 4 terms, grouping is the way to go. So grouping starts by doing exactly how it's called, grouping the first 2 terms together and grouping the second 2 terms together. And within each group, you're going to take out a GCF. So in my first group, my GCF is going to be 3x. I'm going to take that 3x and write it on the outside of the parentheses and then do some division. 6 divided by 3 is 2, and x squared divided by x is x. Then I do 3x divided by 3x. Anything divided by itself is 1. Be very careful if you decide to cancel them out. It doesn't cancel completely so that nothing gets written there. If everything cancels, that means you replace it with a 1, because anything divided by itself, like I just said, will get you a 1. All right, now I need to take the GCF out of my second group between 8x and 4. You might be thinking that the GCF is 4. If you take a 4 out and you try to divide this, -8x divided by 4 is going to get you a -2x. And that's a problem only because you want this and what you end up with here to match up. If I do -8x divided by 4, I'll end up with a -2x and it won't match up. So what that tells me needs to be done is that these positive 4s need to be changed into -4s. Doing that is now going to make it match up because negative 8x divided by negative 4 is going to get me a positive 2x. And the negative 4 divided by negative 4 is going to get me that positive 1 that I need to make it match up. If you notice it was a negative 4 right off the bat, that's even better. You don't have to worry about going back and changing it, but it's always an option to go back and change it if you go with the positive to start with. So once they match up, you are ready to write your answer. The ones that match up, this 2x plus 1 is going to get written in the answer, but only once. Once it's written in there, it's almost like that's gone, and you're going to refer to what is remaining, which is the 3x and the negative 4, and you're going to bring them together as 3x minus 4, and that is your final answer. Now, something that a lot of people tend to forget when we are working on factoring is that every single one of them can be checked by doing some distribution. If I just distribute that 2x through to the 3x and the negative 4 and the 1 through to the 3x and the negative 4, I will end up with what we started with, and you can trust me on this one that it does check out, but it might be worth the time to just make sure it checks on your test. All right, part B, I'm going to do exactly what I looked at in the start of part A, and I'm going to look for a GCF to start. This one does have a GCF. It is kind of tempting to try and do DOPS to start because it does have two terms and it's subtraction, but 8 and 18 are not perfect squares. So I am going to start with a GCF for this one. And the GCF between 8x squared and negative 18y squared is 2. So I divide both of them by 2 and I put that 2 out in front, and then I'm going to divide them out. So 8x squared divided by 2 is a 4x squared, and negative 18y squared divided by 2 is a negative 9y squared. So what's nice about this now, and remember we are factoring completely, which means factor until you can't factor anymore. I do have to see if I can factor it further, and I can. What's left in the parentheses here has two terms, which generally means DOPS, but I just need to make sure that it is the difference, and it is, of perfect squares, which it is. 4 and 9 are perfect squares, and the x and y both have even exponents, which tells me that they are also perfect squares, so I'm going to use my DOPS method. So to start DOPS, I take the square root of each of my terms. Your setup for DOPS is going to be the same every single time. Two sets of parentheses, one with a plus and one with a minus. Now within those parentheses, I'm going to put the result of the square root. So the square root of 4x squared is 2x. That's going to go in the front of both sets of parentheses. And then the square root of 9y squared is 3y. That's going to go on the back end of both sets of parentheses. And then just don't forget to bring down that GCF to show your complete factorization. All right, so we've gone over trinomial AC, GCF, and DOPS. Now we're going to look at part C. You do want to see if all four of those terms have an overall common GCF, but they do not. So I count my terms, and there are 4 of them, which tells me I'm going to do grouping, just like we did in part A. But part A had a little extra bit of a step in the beginning to make it into a grouping problem because it only had 3. This one has 4 to start, so I can start grouping right off the bat. So I group my first 2 terms together, group my second 2 terms together, and then I GCF each group. So my first group has a GCF of 2x squared. You always want to look at that smaller exponent. They have that in common. So I put that 2x squared out in front, and then I divide. These 2's are going to cancel or give me a 1. You can write the 1, but you don't have to. And x cubed divided by x squared is x. Remember the little shortcut we talked about? X cubed is 3x's. And x squared is 2x's. If those cancel out, I'm left with one of them. So that's where that x came from. And then for this one, the x squares cancel, and negative 4 divided by 2 is a negative 2. Okay, so I want to get this x minus 2 when I divide in the next group. So 3x and negative 6 have a GCF of 3. So I take that 3 out. This one does not need to be a negative 3 like part A needed to because it'll all end up working out when I divide. Watch this, when I do 3 divided by 3, they cancel and it leaves me with an x, which is already starting to match up. And then negative 6 divided by 3 is a negative 2, so they do match up perfectly. I'm ready to write my answer just like I did for 8. That x minus 2 that they have in common is going to come down, and then I put my 2 GCFs together, the 2x squared, and it's a positive 3, so I'm going to write plus 3. And that is my answer. And just so you know, for all of these factors, the signs matter, so the negative needs to be with the 2 for part C, and the positive needs to be with the 3, and so on. But you could change the order of all, like the overall factors. So the 2x squared plus 3 could come first, and then the x minus 2. Both of these are correct answers. And same thing goes for part A and part B. You can switch around the order of the factors if that makes more sense to you. All right, number 490. It says, if $380 is invested in a savings account that earns 5% interest per year, determine the amount in the account at the end of 15 years. So we're earning a percentage of interest. This is going to use that growth and decay formula on your reference sheet. So the formula doesn't need to be memorized, but you do need to know how to use it, and you need to know which one to use, whether it's growth or decay. So this word of earns right here tells me right off the bat that this is going to be an increasing function. So I am going to use the plus in my growth for my growth formula. Okay, off to the side, I'm just going to organize everything. APRT, remember it's a party. So it says that $380 is invested. That is my starting amount of money in the savings account. That's going to get plugged in for the starting variable, which is P. It earns 5% interest per year. That percentage is your rate. However, you need to plug it in as a decimal. So you can do 5 divided by 100, or you can scoot the decimal point at the end of the 5 left 2 places, and it'll become 0.05. Either way, you have to convert it to a decimal. So R is 0.05. And then it says, determine the amount of the account at the end of 15 years. So 15 is time. That's going to get plugged in for T. And the fact that it's telling me to determine the amount in the account after that amount of time tells me I'm trying to find that ending amount. So A is what I'm trying to find. So now I'm going to take all of that information and plug it into the formula. So the A stays. P is going to be 380. And then the 1 plus comes down. R is 0.05. And T is 15. So at this point, you can just take this entire thing exactly how you see it and plug it into your calculator. So take a second to do that. And I have the decimal written up here that you should get in your calculator when you type that in. If you did not get that, double check that you plugged in all the parentheses, the decimal point right, and all that good stuff. That is the answer that you should get, and it does tell me to now round to the nearest dollar. Nearest dollar is just essentially the nearest whole number. This one's a little tricky to round because I do want just this number, but I have to look at that digit after it to see if it'll bump it up. That 9 will bump this 9 up. If you bump up that 9, or technically that 89, it's going to bump it up to 90. So rounded to the nearest dollar is going to be 790. The 9 bumps up the 9, which bumps up the 8. All right, moving right along to exponent rules. So for exponent rules, you just really need to know what rule applies, and you need to keep applying the rules until there are no more rules that do apply, kind of like factoring. You keep factoring until you can't factor anymore. So for A, I have division. When you have coefficients that are being divided, there's nothing new there. It still just gets divided. 12 divided by 6 is 2. When you're dividing variables, you have to subtract the exponents. So 12 minus 6 gets me a 6, and 2x to the 6 is my final answer. Now, it's a lot to write, but it might help you out, so I'm just going to go ahead and write it. X to the 12th means there's 12 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's being divided by x to the 6th, so 6 x's. 1, 2, 3, 4, 5, 6. If I cancel out 6 of them from the top and the bottom where they match up, you'll notice that we're left with 6 on top. That's where that 6 comes from. So you can just remember the rule to subtract the exponents, or if it helps you to envision it like that there's 12 on top, 6 on the bottom, you'll be left with 6 on top. You'll be good to go. All right, B, it's very, very important that you notice those parentheses and the 3, or the 3 in the exponent, on the outside. So the 2 and the x squared in the parentheses are both being raised to the 3rd power. So that 3 goes here, and it goes here with this 2. So right here, I have 2 to the 3rd. 2 to the 3rd, you can plug that in your calculator if you need to, or just do 2 times 2 times 2. It's going to get you 8. Now, when I have x squared being raised to the 3rd power, that's a power to a power rule. When you take those two exponents right next to each other like that, the power to a power rule means you multiply them. 2 times 3 gets me 6. So 8x to the 6th is going to be the answer for that one. All right, 3x to the 0. I want you to notice that there aren't parentheses for this one. If I had, like, let's say 3x in parentheses to the 0, that means that whole thing is being raised to the 0, and anything raised to the 0 power is 1. But that's not the case for this one. Only the x is being raised to the 0 power. Because it is being raised to the 0 power, it's a 1, but the 3 was not part of it, so the 3 carries down. It's going to change your answer. 3 times 1 is what you end up with, so your final answer is 3. All right, for the next one, part D, x squared divided by x to the 5th. It is division, so I'm going to subtract my exponents. 2 minus 5. Make sure you do top minus bottom. That's going to be x to the negative 3rd. Now, I am not done because I now need to apply my negative exponent rule. You can never leave them with negative exponents. So your negative exponent rule is to turn this into a fraction. Anything can be turned into a fraction by putting it over a 1. And then you have to flip these around. So the 1's going to end up on top, and the x to the negative 3rd is going to move on down to the bottom, but that 3 is going to become positive. So here's my final answer. So using that little shortcut that I showed you for part A with division, it's kind of that same idea if you liked that. X squared means that there's 2 x's on top, and x to the 5th means that there's 5 x's on the bottom. If I cancel 2 of them, I'm left with 3, but notice I'm left with 3 on the bottom. So it's going to be 1 over x to the 3rd. Again, only use that if it helps you. It's just a little trick. Even if you want to use it to check your work, it's awesome. It's a really, really nice trick to use. All right, next one's a bit of a toughie. We have x and y. There's nothing to simplify on top. Yes, the x and the y are being multiplied, but because they don't have common bases like xx or yy, I can't do anything with their exponents. So I'm going to leave that alone for now as x to the negative 2nd power and y to the 4th. But on the bottom, we have a little bit more that we have to work with because there's parentheses there that x to the negative 3rd is being squared, and so is this y to the 1st technically is being squared. So I'm going to use that power to a power rule. X to the negative 3rd squared means I multiply negative 3 and 2, and that gets me x to the negative 6. Now y to the 1st being squared means I have to do that 1 times 2. 1 times 2 is 2, so y squared is what I end up with. Now, when you divide, you subtract your exponents. This one is tricky. When you do your x's to start, I have negative 2 minus negative 6. When I have negative 2 minus a negative 6, that minus a negative becomes a plus. I'm technically adding 6 to negative 2, which gets me 4. So my answer is going to be x to the 4th, and then the y is much easier. I have 4 minus 2, which is just 2, so the y squared is what I get when I divide the y's. All right, now 4 different rules are going to apply for f, so stay on your toes and make sure you keep going until no more rules apply. I have 2 x's on top. I only have 1 on the bottom. I can't start dividing yet because there's stuff that can be simplified on top and bottom. I wouldn't even know which x to start dividing right now, so I need to simplify the top first. They are being multiplied. When you are multiplying 2 terms together, you add their exponents. So 3 plus 4 gets me 7. So my top is going to be x to the 7th. On the bottom, I have a power to a power. 5, 2. When you have power to a power, it kind of looks like they should be multiplied, and they are supposed to be. So 5 times 2 is 10. That gets me x to the 10th. Now that's 2 rules that I've just applied so far, multiplying and power to a power. Now I have a fraction all set up with 1x on top, 1x on the bottom. I'm ready to divide. When you divide, you subtract your exponents. Top minus bottom will get me a negative 3. 7 minus 10 is negative 3. Now I'm not done because that is a negative exponent. I have to do what I did in part D, turn it into a fraction, and then flip-flop it. So I'm going to have 1 on top and x to the positive 3rd on the bottom as my final answer. So there you have it for exponent rules. Let's move right on to solving. Now on your exam, it's going to be a lot like your last test where the solving is mixed up with different types of functions. So the method that you're going to use depends on the type of function that you have. So if you have a linear function, it just means that there's an x in it. And all you want to do is get x alone. No matter what method you use, sometimes you got to move x over to the other side. Sometimes you got to move the other numbers away from the x. Your overall goal is to get x alone. Okay, the next one is going to be quadratic function. If you have a quadratic, it means that there is an x squared in it. So there are two different ways that you can solve a quadratic. The one I'm going to mention first is the quadratic formula. The quadratic formula works every single time. The other method you can use is factoring and then using that T-chart or T it up like we talked about in class. But this method does not always work. Quadratic formula will work whether it's factorable or not. So that's really the go-to I'd prefer you use. But again, factoring is a little bit shorter, but you got to be good at factoring for that method to apply. So up to you. Test if something's factoring if you want to. I'm going to go over, a couple different methods for each one of these. So the setup for a quadratic that you absolutely need to know is that it's an ax squared plus bx plus c equals 0 form. Most specifically, you have to make sure you're equal to 0 before you start using either of those methods. Okay, and last but not least is an exponential function. Exponential just means that it has an x in the exponent. All these x sounds. Exponential has an x in the exponent. They all go hand in hand. Whenever you have this type of function, you can use two different methods also. The method that works every single time is logs. So that's, again, kind of like the quadratic formula. It's the method that I recommend because there's not much thinking involved. You just have to remember that log process. The other method is called common bases. And very similarly to the quadratic functions, common bases is a method that does not always work. So you can steer away from that. Unless common basis is something that you can recognize right off the bat that it applies, it is definitely shorter than log, so use it if you are good at it or if you think that you really, really understand when it applies and when it doesn't. Okay, so what we're going to start doing is looking at each one of these functions and seeing, what type of function it is and then go from there. So the first one, 492, has an x squared in it. That tells me right off the bat that it is a quadratic, and I'm going to go ahead and solve it using that quadratic formula. Now, I can't use the formula until I get this equal to 0. So I have it equal to 18x right now. To move a positive 18x to the other side, I'm going to subtract the 18x over. Now, a common mistake with this one is not writing it in the correct order. So refer back to this that I'm starring up here at the top. That's an ugly star. You have to make sure you have the x squared term first, then the x term, then the number. So 3x squared is going to come down first, then the minus 18x, then the minus 48, and that'll end up being equal to 0. Whoops. So it's in the right format. I'm ready to go. I'm going to use the quadratic formula. If you want to look, this one actually is factorable. If you guys want to look at my key on Blackboard, you can see the factoring method. I'm going to go through that quadratic formula method just so you can really, really get the hang of it. So the quadratic formula needs an a b, and a c. A is the number in front of x squared, which is 3. B is the number in front of x, which is negative 18. And c is the number by itself, which is a negative 48. Now, the quadratic formula is given on the formula sheet for your exam, so you don't need to have it memorized. I'm just going to go ahead and write it on here so we have it as a reference. And then what you're going to do is use that a, b, and c that we listed off to the side and plug them in where you see the a, b, and c in the formula. So I start by writing x equals, and I copy down the negative from the formula. Now I'm going to plug in b, which is a negative 18. So what's going to happen right here with that negative is it's just going to end up being a positive 18, which is nice. I love positive numbers. So after that comes the plus or minus in the formula, and then the big square root. Okay, now that b that I'm plugging in is negative, so I put the parentheses, the negative 18, and then the squared comes down. Next in the formula is a minus 4, and then I have to plug in times a times c. I'm going to use parentheses. You can use the times button. It's completely up to you. But times a is going to be times 3, and then times c is going to be times negative 48. And that's all over 2a, so all over 2 times 3. Okay, now I can't show you on this how to plug it in the calculator, but please hear me out when I explain it to you. You have to plug in the top first, and then press enter. You'll get an answer for the top, and then you'll type in divided by 6. Don't do divided by 2 times 3. That will mess you up. You have to figure out what the bottom is first, then divide by 6, enter. Okay, so when you type in the whole top, you are going to end up getting 2 different answers for this one, and you have to plug it in first with the plus and then with the minus. So that kind of changes your answer, and that's why you end up getting 2. Okay, so when I plug it in with a plus, the answer should be 8. Then when you plug it in with the minus, you should end up getting -2. So practice plugging that in. Make sure you end up ultimately dividing it by 6, but your answer should be 8 and -2. Okay, something that is kind of nice about quadratics, and it's up to you if you decide to do this, you can take this function that we got equal to 0 and plug it in to your y equals. When you do so, this is a very rough sketch, so please don't mind my graph, but you'll notice that it looks a little bit like this. It crosses the x-axis here at -2, and it crosses the x-axis at +8. This is not a method of solving that you are allowed to do for credit, but it is absolutely a nice way to check your answers. Let's say I got crazy answers like -7 and, I don't know, 11. And then I notice when I graph it that it crosses the x-axis at -2 and 8. That would tell me that my answer is wrong, and I would try and go back and fix it, especially if I have extra time at the end of the exam. All right, 493 is a linear function. I know that because it just has an x in it. No x squared, no x in the exponent, just an x. So your goal is to get x by itself. Now for this one, I have an x on both sides of the equation. So in order to get x alone, I've got to get both of those together to start. So I'm going to move this -7x to the other side by adding 7x to both sides. So those 7x's cancel, and then 3x plus 7x gets me 10x over here on the left side. The -7 comes down, and then that is equal to 13. This is like that home-based standard form that's so great to work with. To get that x alone, I get rid of what's being added or subtracted first, which is the -7. Then I get it to the other side by adding the 7 over. The 10x comes down, those 7's canceled, and 13 plus 7 is 20. So my last step here is to divide by 10, and I end up with x is equal to 2. Which I can plug that x value of 2 back in for x here and here to check to make sure that the left side ends up equaling the right side. But checks are optional. I just highly, highly recommend. Right, 494 is also a linear function because, again, there's no x squared and there's no x in the exponent. So you just have to do what you know to get x by itself. For this one, I have the distributive property that I have to start with. So first I have 2 times 3x, which is 6x, and then 2 times 2 is a 4. Over here I have a -4 being distributed through. Watch out for that negative sign. -4 times x is a -4x, and then -4 times this -6 is a +24, and that is equal to 50. So now I'm going to go ahead and combine my like terms. This one's different than the last one that we did because the x's are on the same side of the equal sign. So I don't add them over or subtract them over or do any opposites. I just combine them. So 6 minus 4 is 2, so I get 2x. And then I'm going to combine these numbers too to simplify my life a little bit. 4 plus 24 is 28, and that's equal to 50. And then here we are at that home base form again. Get rid of what's being added or subtracted first. I'm going to subtract that 28 from both sides. So the 2x is going to come down, and then 50 minus 28 gets me 22. And then I divide both sides by that 2, which is being multiplied by the x, so I do the opposite, and I get x equals 11, which can also be checked. All right, 495, I notice right away that there's an x in the exponent, which tells me it's an exponential function, and I'm going to use logs to solve it. So this one actually does work with common bases, so if you are the kind of person that prefers common bases, absolutely do that method. Check my key if you want to, but I'm just going to use logs because it's that method that works every time that I really want you to hit home on. So the log method, you start, the second you see an x in the exponent, you start by writing the word log on both sides. I'm actually going to add something up here to your notes before we continue with this problem. The setup for this one is that the number raised to the x is alone. So that's the setup, is that the number raised to the x power is alone. We're going to get into a couple that don't necessarily have that setup, and I'll explain that a little bit more once we get to it. But for this one, notice the 2 was being raised to the 3x plus 7, and it's alone. There's nothing else here in front of it to worry about. It's all by itself, so that's why we were good to start taking the logs right away. So what I did is I wrote the word log on both sides. Nothing else about this changed. The whole point in writing the word log is to take this exponent and drop it down. That's what the log function does. So 3x plus 7 is now out here in front of the log of 2, and the equals log of 16 just carries down. Okay, so the whole purpose of the log was for the exponent to come down. Because I did that log, that exponent came down and I'm done using the log. So the log served its purpose, I can get rid of it now. So right here between the 3x plus 7 and the log 2, you can see that there's no symbol, which means they're being multiplied. So to get rid of that log of 2, I'm going to divide both sides by the log of 2. So on the left side, when those log 2's cancel, I'm left with 3x plus 7. What I really want you to see on this right side about plugging it in your calculator, when you hit the log button, it's going to give you an open parentheses. You have to make sure you close that. Then divide it by log of 2, and then close that one as well. You should end up with a 4. Once you're here, this is actually turned into a linear function now that I've simplified this. I get rid of what's being added or subtracted first to make sure I can get that x by itself. So I subtract that 7 over, and I get 3x is equal to negative 3, because 4 minus 7 is negative 3. And then to get rid of that 3 that's being multiplied to the x, I divide by 3, and I get x equals negative 1. Again, common bases would have worked for that one. The method is a little bit shorter, but there's a little bit more thinking involved, and it doesn't always work. But if you prefer common bases, just check my key, and you'll be able to hopefully have a little bit easier time with it. All right, the next 4, same direction, same idea. I have to solve the following by figuring out what type of function they are. So 496 is a quadratic because I have this x squared right here. To solve a quadratic, I'm going to use the quadratic formula in this video. I can't use the quadratic formula until it's equal to 0. So to get that negative 3 to the other side, I'm going to add 3 to both sides. Now remember, you have to be in that ax squared plus bx plus c form. So the 2x squared is the first term that I write, then the x term, so plus 5x, and then the number by itself. So the plus 3 comes down, and that's equal to 0. But this one is also factorable, so if you prefer factoring, it's AC, so it's definitely the longer type of factoring. I think they're about the same length for these ones, the factoring method and the quadratic formula. But I'm just going to use the quadratic formula method because, again, it's the one that works every single time. So for this one, now that it's equal to 0, I can say that A is that first number, which is 2, B is the second number, which is 5, and C is that third number, which is 3. And I'm going to just write out that formula, which is on the reference sheet. You don't need to memorize this. It's starting to get a little messy here. And then I'm going to plug in that 2 for A, 5 for B, and 3 for C in the formula. So x equals negative comes down. B is a positive 5 for this one, so it's going to stay negative because of that negative in the formula. The plus or minus comes down, big square root in parentheses. B is 5, so I plug 5 into those parentheses. The minus 4 comes down. Times A is going to be times 2. Times C is going to be times 3. And that's all over 2 times A, so 2 times 2. Now remember what we talked about in the first one. You plug in the top first with a plus, then with a minus after. But first with a plus, then you press enter. Then you divide by 4, and then press enter again. Don't do divided by 2 times 2. It will be messed up on your calculator. Okay, so again, plug it in with a plus first, then plug it in with a minus. Take a second to do that. You can pause the video if you need more time. When you plug it in with the plus, you should get negative 1. When you plug it in with the minus, you should get negative 1.5. If you don't get those, try plugging it in your calculator again. Something that a few people do mess up on, when you hit the square root button in your calculator shows a parentheses after. That is not this parentheses. You need to then type in the parentheses 5 squared. This one is much different. It's just showing you what's under the square root. You still need to do that initial parentheses. So if that's something that maybe you didn't type in, it might be the reason that you're not getting the answers, if you're not getting the answers. All right, moving on to 497. X is up there in the exponent, which tells me this is a log problem. Now the setup for log is that there needs to be a number by itself raised to the x. 5 is by itself on the left side, so this is in the correct setup, so I'm good to start by writing the word log on both sides. Now you really only need the log on the left side because its purpose is to take that exponent and bring it down in front, but what you do to one side you have to do to the other, so you have to write the word log on the right side as well. Okay, so that x minus 4 comes down in front, the log of 5 carries down, and then that's equal to the log of 275. Okay, the log served its purpose. It brought down that x down in the front, so this is solvable now, so now I'm going to get rid of that log of 5 because, again, it served its purpose. So it's being multiplied to the x minus 4. To get rid of it, I am going to divide by the log of 5 so that these log 5s cancel, and I'm left with x minus 4. And remember, when you're plugging these logs in, it's going to open a parentheses. You have to make sure you close that parentheses before you divide by the log of 5. Now, when you plug this in, you will get a nice, long, ugly decimal. So I shouldn't have said nice. It's definitely not a fun decimal. You can't round. I know it says to round to the nearest tenth in the directions, but you can't round until your final step. And we're not done. X is not by itself, so I have to write out this whole decimal. So just check that you get this same decimal that I'm writing down. 3.48 and so on. Okay, once you get that from plugging it, those logs into your calculator, you want to get this x by itself, which means I have to get rid of that minus 4, and I'm going to do so by adding 4 to both sides. So I get x is equal to 7.4898, blah, blah, blah. And my goal is to round this to the nearest tenth now because that x is by itself. So tenth is this place right here, but you have to look at the number after it to see if it'll bump that up. 5 or above, give it a shove. That 8 does bump that 4 up. So it turns into 7.5 is your final answer. All right, moving on. I am on 498. So this one has an x in the exponent as well. Problem is, there's a number there that's not being raised to the x. Only the 1.03 is being raised to the x. I need that to be by itself before I can take the log of both sides. Now you can't do 50 times 1.03. The reason for that, if you're at all curious of why you can't do that, is because of PEMDAS. You have to do exponents before you multiply. And there's an exponent in this problem. The issue is you can't actually apply that exponent. And if you can't do the exponent, you can't do the multiplication. So that's why you can't multiply the 50 by the 1.03. But you do still need to get rid of that 50. Because they're being multiplied, you can get rid of it by dividing by 50 on both sides so that those end up going away and that 1.03 raised to that x power is by itself. Now on the right side, 230 divided by 50 gets me 4.6. So it's really not that bad of a problem. Honestly, I think it looks a little bit better without that 50 there. But now we're good to go with our log method. And common basis definitely doesn't work here. If you like common basis better, this is why it's just kind of nice to know that one log method because it will always work. So I have that number by itself. I am good to take the log of both sides and do that same method that I just did for the last log problem. So that exponent of x over 12 is going to come down in front. So I'm going to write x over 12 times the log of 1.03 is equal to the log of 4.6. Sorry guys, it's getting kind of late and I am writing very sloppy, but hopefully you can still read that. So your goal is to get x by itself. I have used the log to bring that x in the exponent down. So now the log has served its purpose and I can get rid of it. It's being multiplied here, so I'm going to get rid of it by dividing by the log of 1.03 on both sides. So these end up canceling out and I'm left with x over 12 equals, and this one also is not a nice number. You have to write out the whole thing because x is not by itself yet. So I'm just going to copy it down. You should get 51.62 and so on. So like I said, we're not done. That's why we're writing out that whole decimal. You're trying to get x by itself. X is being divided by 12. So to undo that divided by 12, I'm going to multiply by 12 on both sides. So when you multiply 51 point blah, 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 blah by 12, you end up with 619.53375, and so on. Which at this point, you can actually round that to the nearest tenth. That's a decimal. It's a little ugly. So the nearest tenth is one place after the decimal point, but you want to look at that digit after it to see if it'll bump it up. That 3 will not bump it up. So my final answer is 619.5. All right, last problem for these kinds of equation solving. So for this one, I noticed the x squared, which tells me right off the bat that it is a quadratic. When you have a quadratic, you use the quadratic formula, and you must be equal to 0. So I need to move that positive 1 over by subtracting 1 from both sides. So I end up with 4x squared minus 12x, and I can combine these like terms to make sure I only have those a, b, c. Positive 6 minus 1 gets me 5, and I'm equal to 0. So using that quadratic formula, again, I need an a b, and a c. A is the number in front of x squared, which is 4. B is a negative 12, the number in front of x, and c is a 5. So I have my a, b, and c now, and I'm good to plug it into that quadratic formula, which again is on the reference sheet, so you don't need to memorize it. I'm just going to write it down here for your reference. So for this one, when I go to plug it in, the x, the equals, and the negative all come down, and then I plug in b. B is negative again for this one, so I end up with that double negative, which is going to turn into a positive. So I have positive 12, the plus or minus comes down, and so does my big square root. I bring down the parentheses, and I plug in b. B is negative 12, and then the squared, minus 4 times a, which is 4, times c, which is 5, all over 2a, so all over 2 times 4. So same as the last couple quadratic formula problems we plugged in, you plug in the top first with the plus, press enter, then for this one you're going to divide by 8, then press enter again. Then you'll plug it in with a minus, enter, divided by 8, enter. So when you plug it in with the plus, you should end up with an answer of 2.5. When you plug it in with the minus, you should end up with 0.5. As your two answers, 0.5 and 2.5. Moving right along, it is solving continued, but these are a little bit different situations. So for 500, believe it or not, we've done 500 questions. It says, given that f of x is equal to 2x minus 10 and g of x is equal to x plus 3, solve the following. So f of x being 2x minus 10, and g of x being x plus 3, I'm going to use part A, which says f of x plus g of x. I'm going to plug in what f of x and g of x are. So in place of f of x, I'm going to plug in 2x minus 10. That plus sign from the formula is going to come down, and now I'm going to plug in the g of x, which is x plus 3, and then that equals 32 just comes down. And I'm just going to go about solving this. So I have two x's. It's a linear function. I just have to get x by itself. And my x's are on the same side of the equal sign. So I'm just going to combine them. No moving it over to the other side because they're on the same side. So 2x plus 1x is 3x. And then I'm going to combine these numbers. A negative 10 plus 3 is a negative 7. And that's equal to 32. Okay, so now I'm in that standard form where I can just get x by itself, get rid of what's being added or subtracted first. To get rid of a negative 7, I'm going to add 7 to both sides. So I get that 3x is equal to 39. And then divide both sides by that 3 with the x, and I get x is equal to 13. And I'm going to do that same setup for b, except now the format of the equation is a little bit different. But f of x is still here to start, and I'm going to plug in 2x minus 10. The equal sign is going to come down, and then I have to plug in that g of x, which is x plus 3. So still a linear equation, because again, I only have an x, no x squared, no x in the exponent, so a linear equation. But my equal sign is between my x's for this one. So to get my x's together, I have to do the opposite to move one of them to the other side. I'm going to move this 1x over. And since it's a positive 1x, I'm going to subtract 1x from both sides. So those cancel out. 2x minus 1x on the left side gets me a 1x or just an x. The minus 10 and the equals 3 carries down. To now get rid of what's being added or subtracted first, I'm going to add the 10 to both sides, and I get 1x is equal to 13. And that's actually my answer. If you did continue on divided by 1, you still end up with x equals 13. And it's just a coincidence that part A and B were the same answer. That is not always going to be the case. For 501 and 502, we've got those out of the ordinary equations, and you'll see what I mean when I start to solve them. So for 501, I start with the distributive property like you would anytime you have the distributive property in an equation. 3 times 2x is 6x, and 3 times 2 is 6. And that's equal to 6x plus 6. So you might notice right off the bat that the left side is identical to the right side. That's what makes this out of the ordinary. But the thing that might trip you up when you continue to solve this is notice the x's are on opposite sides of the equal sign. So just like the last problem we did, I'd have to move one of them over to the other by doing the opposite operation. And when I go ahead and do that, 6x minus 6x on both sides cancel, and I end up with 6 equals 6. There's no x to solve for. When that happens, you have two situations. You either have infinite solutions or no solutions. The fact that I end up with 6 equals 6, or even referring back up to here where the left side was completely identical to the right side, tells me that no matter what number I plug in for x, it will end up checking out. I could plug in a 1, a 2, a 3, a 4, it's 5.5, decimals, negatives, anything. It's always going to work. So there are infinite solutions, and you have to have that written out because that is the answer, infinite solutions. All right, 502, same setup, but you'll notice a little bit difference when we start actually writing this one out. So I do distribute, just like I did in the last one. 2 times 3x is 6x, and 2 times 8 is a plus 16. And then the equals 6x plus 8 just carries down. When I do what I did in the last one and I go to subtract the 6x from both sides, the same situation happens and it cancels on both sides. But I end up with 16 equals 8, and we know that that is not true. Because that's not true, what that tells me is that I could plug in a 1 here for x and a 1 here for x, and it's always going to be different no matter what. The left side will never equal the right side. So that means that the answer is no solutions. It is impossible to have a solution for this one. A negative, a decimal, whatever number, it will never work. So no solutions for 502. All right, next one, still solving equations, but just a little bit different because we are having literal equations, which means that there are a lot of letters, more letters than numbers for that matter. So for A, when there's different variables in the same problem, you need to pay attention to what you're solving for. Part A is asking me to solve for the letter U, so that means I need to get U by itself. So right now, you notice that U is being multiplied by THIS and it's being divided by T. You have to get rid of the divided by T first because the THIS on the top, to get rid of that I'd need to divide by it, and there's no space to divide by it right now because it's already being divided by T. So I've got to do that part first. To undo divided by T, you're going to multiply by T on both sides so that those T's cancel. You're left with U, THIS equals, and GO times T is just GOT, or GOT. Okay, again, you're still trying to get U by itself. It's not quite there yet. It's being multiplied by this. So to get rid of this, I'm going to divide both sides by this so that these all cancel. U is by itself, and you just leave your answer like you see it, got over this. You guys have got this. You will do well in this final. Just keep pushing through, keep studying. Okay, you got this. Next one, just another example of a different literal equation. I'm solving it for A, which means get A by itself. So I've got to get rid of that minus 2B and that minus 4. So I'll get rid of the 2B first. It really doesn't matter which one you get rid of first. But because it's a minus 2B, I do the opposite and I add 2B to both sides. Now, when you do something like this, I have a Z plus 2B. Those are not like terms, so I write it exactly how I see it. Z plus 2B equals A minus 4. That all just carries down. You know, A is almost by itself. I've got to get rid of that minus 4 by doing the opposite, adding 4 to both sides. Same situation, that 4 doesn't combine with anything, so it just carries down. That's equal to A. I've got A by itself. That is my final answer. All right, moving on to the next page. Question 504. I've got this or in here. That doesn't mean solve one or the other. That or is part of your overall thing to solve. So I am going to use that or to split them up, but I'm going to solve each one separately. And I do solve both of them, not one or the other. So for 11 plus r is less than or equal to 12, I'm going to get rid of that positive 11 by subtracting 11 from both sides so that those 11s cancel. And I get r is, make sure you know these symbols, that is a less than or equal to, and 12 minus 11 is 1. The word or comes down for now, and I'm going to solve the other one. So 7 and r are being multiplied. I'm going to divide both sides by 7, and I end up with r is greater than 5. So what I do with that now, because it does say in the directions to solve and graph, I have solved, this is technically my answer, but I need to graph it on a number line. So my important numbers in this problem are 1 and 5, so I just need to make sure that I have a 1 and a 5 on my number line. Okay. Now the signs determine whether it's going to be an open or a closed circle and which direction I shade. So that or equal to tells me that I need a closed circle over the 1. The one without the or equal to is going to be an open circle, telling me that that 5 is not included. Numbers that are following this r is greater than 5, 5 is not included in that because 5 is not greater than 5. That's what the open circle represents. Now going back to the 1, I have a less than or equal to. Less than means I'm going to shade to the left where numbers are less than 1. R is greater than 5 with that open circle. Numbers are greater than 5 to the right. So that is my graph of my solution for number 504A. All right, next one is a little bit tougher with its setup, but look at where x is. I've got two inequalities in the same setup. So I still have to get x by itself, but I have to take into consideration that I have a symbol here and a symbol here. It's like I've got 3 portions. So to get x by itself, I want to get rid of that 3 first because you always get rid of what's being added or subtracted first. It's a positive 3, so I'm going to subtract 3 from all 3 portions of this. So the 3 cancels out here. 15 minus 3 on the left side is 12. The less than symbol comes down. My 2x comes down. The less than or equal to comes down, and then 23 minus 3 is 20. So now same idea, trying to get that x by itself. I need to get rid of the 2. 2 is being multiplied to x, so I'm going to divide all 3 portions of this by 2. Divide all 3 portions of this by 2. And the 2's are going to cancel out in the middle, leaving me with an x. Those symbols all carry down. On the right side, 20 divided by 2 is 10, and on the left side, 12 divided by 2 is 6. So I'm going to put this on a number line, making sure I have a 6 and a 10 on it, because those are my crucial numbers. So 6, 7, 8, 9, 10. Made it a little long, but that's okay. So using that same mentality that I did in the first one, this right here with the or equal to is going to be a closed circle. The one with the 6 not having the or equal to is going to be an open circle. And then be very, very careful about how you shade this. The cheat way of looking at it is that when you look at your solution, the x is between the 2 numbers. So you're just going to shade. Oh, I circled over the 7. I didn't even notice it. Whoops. Let me just fix that real quick. Sorry, guys. Open circle around the 6. So the x being between the 6 and the 10 means that the shading is going to be between the 6 and the 10. That is very ugly shading. There we go. A little bit better. Make sure that you can tell that that is a closed circle around the 10. All right. Another way of looking at it is looking at each individual inequality. The first one is x is less than or equal to 10. So from the 10, I wanted to shade to the left. But this tells me over here, I'm just going to use purple to make it stand out. This right here says that 6 is less than x. If 6 is less than x, that means that x is greater than 6, and you would have shaded to the right of the 6. So if it's right of the 6 and left of the 10, the shading is between the 2. All right, number 505, going back to a formula that we previously used. It says a population of 53 fruit flies is increasing at a rate of 6.5% per day. Determine the number of days it will take for the fruit fly population to double. The fact that it's increasing at a percentage tells me that I'm going to use my growth formula again, which is on the formula sheet. You can just copy it down from here. You would just need to know to flip back to that formula sheet, and you also need to know how to use it. So off to the side, I need to determine A, P, R, and T. Remember, it's a party. So the population of 53 fruit flies is increasing at a rate of 6.5% per day. But that tells me I'm starting with 53 fruit flies, so that's going to be P, your principal or your starting amount. And then I have a rate of 6.5%. Now, 6.5% can be converted to a decimal. I know it looks like a decimal, but the fact that it has this percent symbol means I need to convert it by dividing it by 100 or moving that decimal point left 2 spaces to get me 0.065. So either way, you end up with 0.065. Now, here's why this one differs from the last one. It says determine the number of days. T is what I'm trying to find. And it says determine the number of days it will take for the fruit fly population to double. If I'm starting with 53, my doubled amount of that is going to be 106. Just do 53 times 2 to get that 106. So this one gives you A. So now that I have my information filled out over there, I know I need to solve for T. I'm going to plug in all my information. So 106 gets plugged in for A. That's going to be equal to P is 53 times 1 plus 0.065, and I leave the T up there in the exponent. If you don't like T because it kind of looks like a plus sign, you can use an X instead. That's perfectly fine. All right, now when I go to solve this, I notice that since I'm solving for a T up in the exponent, it's an exponential function, and I need logs. So I look at what's being raised to the T, and it's just that 1.065 and not the 53. So I can't take the log of both sides until I get rid of that 53, and I do so by dividing both sides by 53, ultimately canceling that 53 out, just like I need. So 106 divided by 53 is 2, and that is equal to, I'm just going to add those right now and get 1.065 to the T. So now I'm good to start solving this with logs. You start by writing the word log on both sides. So the log of 2 is equal to the log of 1.065 to the T. The whole point in taking the log is to get that exponent of T out of the exponent and drop it down in front. We're used to these being flip-flopped where the T is on the left side of the equation, but it's still the same process. So the log of 2 carries over, the T comes down in front, and it's the log of 1.065. Now, if I'm trying to get T by itself, T is being multiplied by the log of 1.065, so I'm going to divide by the log of 1.065. So these cancel. It leaves me with T by itself, and remember, when you hit log, it opens the parentheses. You have to close the parentheses before you divide. So you should hopefully get the answer of 11.89566,105. I think that's what you get. Let me just double check when I plug that in my calculator because I have 11 written as the answer. Let's see. So when I type that in, the log of 2 divided by the log of 1.065. Yeah, my decimal is wrong. Sorry. Scratch that. That's not what you should get. Okay, when you do the log of 2 divided by the log of 1.065, you should get 11.006739,041. Sorry about that. It seemed wrong for sure. Okay, but then when I round that to the nearest whole number, like the directions say, it ends up taking 11 days for the fruit fly population to double. Sorry about that. I'll have to fix my key. Must have just hit the wrong key at some point. All right, moving right along. 506. So it says a rocket is fired upwards following a path given by y equals negative 16x squared plus 112x, where y represents the height in feet above the ground and x represents time in seconds since the rocket was fired. Determine how many seconds, so we're solving for x because it said x represents time, it takes for the rocket to reach ground level. So I know that y is my height. Ground level is going to mean that y is 0. So I'm going to plug in 0 in place of y to start. So it's 0 equals negative 16x squared plus 112x. Now this one can absolutely be solved with factoring. I am going to go ahead and use the quadratic formula because this is a quadratic, and that's the method that works every time. Like I keep saying, it's a good go-to. If you don't want to memorize a lot of methods, this is the one to use. So negative 16x squared, that x squared tells me that it's a quadratic. I'm solving it because it asked me to figure out what x is or figure out how many seconds it takes. So I'm using the quadratic formula. Now the trick with this one is for the quadratic formula, you guys know you need a, b, and c. A is the number in front of x squared, which for this one is negative 16. B is the number in front of x, which for this question is 112. And then I've got nothing over here for c. There's technically a c there. It's plus 0. No one ever writes plus 0 because it doesn't change the value of anything. So that's why it's not written there. But technically everything has a plus 0 on the end. It doesn't change the value of anything. So I'm going to go ahead and write out my formula. X equals negative b, straight from the formula sheet. If you write it so many times, you probably start to memorize it. And then I'm going to plug everything in. So my x, my equals, and my negative from the formula come down. B is a positive 112, so that negative sign is going to stay negative for this one. The plus or minus comes down. My square root comes down. And I use my parentheses now. Parentheses, b is 112 again, squared, minus 4 times a, which is negative 16, times c, which is 0, all over 2 times a, so 2 times negative 16. So same thing we keep going over. Type in the top with with a plus first and then hit enter. Then you're going to divide by, if you need to do this first, go for it, but it's negative 32. So you divide by negative 32 and then press enter. Don't divide by 2 times negative 16. It may mess up in your calculator. All right, so when you plug it in with a plus first, you end up getting x equals 0. When you plug it in with a minus, you should end up with x equals 7. So when it says determine how many seconds it takes for the rocket to reach ground level, it's not going to take 0 seconds. 0 seconds is before it starts, or technically the very, very moment it starts. So your answer for this one is going to be 7 seconds. Now on my key on Blackboard, I show the factoring method for this. If you want to check that out and you prefer factoring, definitely go check that out. And make sure that you are doing it correctly. It would have been a GCF factoring. Moving on to the next page. Got a lot to do still. So for 507, part A, it's saying to graph y is greater than 4x plus 2. Now that we've graphed parabolas at this point in the semester, there's 2 different ways that you can go about graphing this. I'm going to go over the original way that we learned, which was mx plus b, using m and b and all of that. But what you could do is plug this into the y equals in your calculator and pull up that xy table and just plot those points. Okay, that's absolutely one of the ways. A lot of people prefer that at this point in the semester because they're so used to doing it for parabolas. You can absolutely do that. Okay, so the only thing with that is you are using y equals, and you still need to go back and refer to this symbol towards the end, which we're going to talk about with both methods. But when I use my mx plus b, m is the number in front of x, which is 4. B is the number by itself, which is 2. Now, when you write out your slope, it has to be a fraction for that rise over run. Because it's a positive 4, it's going to be up 4, and you always run right. And B tells you what you start at. So I'm going to start at 2, my B, my y-intercept. Then from there, I'm going to go up 4, right 1, up 4, right 1. When you're out of space to go up 4, right 1, you're going to go down 4, left 1. Do the complete opposite to make sure it still looks like a line. A benefit of doing it this way, plugging it in the y equals, is you can hit the graph button before you pull up your table just to see what your graph is supposed to look like, and then kind of go from there. Okay, so don't connect them yet. This is where the symbol comes in. So I have a greater than. Because it doesn't have the or equal to, it tells me it's going to be dashed, and greater than means I'm going to shade it up. So I'm going to use a dashed line to connect these points, and then I'm going to shade it towards the top of the graph, so everything above that line. Okay, if you guys need more time to graph it, just pause it. I'm just going to keep moving through so this video doesn't end up being, forever long. So part B says name a possible solution to this inequality. A solution would just be any point in the shaded area. Something that's super important that you know is that these points on the dashed line are not solutions to this inequality. If it's on a dashed line, it is not a solution. You want to pick something in the shading. It doesn't matter what point. There's infinitely many answers. I'm just going to pick -6, 2, this one right here. All right, next one, 508. So solve the following system of equations graphically. When you have a system, it means we're working with 2 in this course. So I'm going to graph each of these at a time, and then your answer is going to be where both the equations are the same. So let's graph them and you'll see what that ends up looking like. So I have y is equal to 7 minus 3x. That's in y equals mx plus b form. That's exactly what I need to start graphing. And I forgot to mention that up here. This one was already in that y equals mx plus b form, so I didn't have to alter anything. It was good to go just like this one is. So I'm going to state that m is -3. Turn it into a fraction by putting it over a 1. Because it's negative, it's going to be rising down. I know that sounds stupid, but the negative tells me to go down. Then you always go right, and b is 7. So I'm going to start at 7 and go down 3, right 1, down 3, right 1, and so on the whole way. I do have enough space to take one more point by going up 3, left 1, the complete opposite. I kind of switched this up a little bit. This one doesn't have inequality symbols, so there's no shading, there's no worried about solid or dashed, you just connect it. Hopefully straighter than that attempt right there. You just connect your points and put arrowheads on the end, because that line does continue even though the grid ended. So we are done with the first one of the system. Now I need to work on the second one. Now the problem with the second one is it's not in y equals mx plus b form, so you have to get it there. It's a literal equation where you have to get that y by itself. I've got to get rid of the 2 and the -4. Always get rid of what's being added or subtracted first, so to get rid of that -4, I'm going to add 4 to both sides. Now what a lot of people tend to struggle with this is this part right here. You have an x and a number. Those can't be combined because they're not like terms. So the -x comes down and the +4 comes down as 2 separate terms. Now I still do not have y by itself, but I'm getting closer. I have to get rid of that 2. The 2 and the y are being multiplied, so I'm going to get rid of the 2 by dividing everything by 2. So those 2's on the left cancel, and I end up with y equals, this is a -1 in front of the x. I can't do 1 divided by 2. It's just going to simplify to 1/2 anyway. So I'm going to leave it as -x over 2, and the 4 divided by 2 is 2. So just like we said for the last problem, you can plug that in your y equals and pull up the table and graph it that way, or you can do your m and b. So b is 2, and m is just the number in front of x, which is -1/2. It's already a fraction, which is kind of nice. You don't have to turn it into 1. So being rise over run, I'm rising a -1, which means down 1, and I'm going to run right 2, starting at 2. So I put 2 on the y-axis, and I go down 1, right 2, and right away, I hit a point, which is a good sign. I'm going to keep graphing this because I do need to finish out my graph by going down 1, right 2, and I'll go up 1, left 2, complete opposite once I finish the right side. And again, no shading, no solid or dashed. These are equations, so I just connect it with a regular line, arrows at the end. If you need more time to graph it, just take a second to pause this. But I'm going to go ahead and talk about the solution. So when you're solving a system of equations, your answer is going to be where the 2 lines are both at a same point. So this point where they intersected right here that I'm highlighting in green, that's going to be your solution. It's the only point that the 2 lines share, that they have in common. So that's going to be your solution. It's going to be the point 2, 1. Right, this next one is a little bit different. So for 509, whoops, 509. I still have a system. So that same idea where you have to do two on the same grid, but these are two inequalities. So we'll talk about what the answers mean, once we get there, but I need to graph each of these. So my first one is y minus 1/4 x is less than 5. It's not in that y equals mx plus b form that I need, so I have to get y by itself. If I'm trying to get this y alone, I've got to move that minus 1/4 x to the other side, and you do so by doing the opposite. So I'm going to add 1/4 x to both sides, making that cancel out. So the y comes down, my less than comes down, and 5 plus 1/4 x comes down as two separate terms, because just like we talked about on the last one, if 5 doesn't have an x, the 1/4 does have an x, so I can't combine them. They're not like terms. But now I'm in that mx plus b form. I've got y by itself, so I'm going to start graphing this. You can plug it in the y equals in your calculator and pull up the table, or you can do what I'm doing and state your m and b and go from there. So m is the number in front of x, which is 1/4. It's positive, so I'm going to rise up 1, right 4. And b is the number by itself, which is 5. So when I go to graph that, I put a point on 5 on the y-axis, and I go up 1, right 4, up 1, right 4, or down 1, left 4, down 1, left 4. Now don't connect them quite yet. It all depends on your symbol. For this one, I have a less than. Because it doesn't have the or equal to, that tells me that it's dashed, and less than is going to be a shade down. So I'm going to dash this line, and I'm going to shade everything beneath it. So I'm shading this one down. And that one's good to go. So now moving on to the next one, so I can finish up this system. I have y is greater than or equal to negative x. So that same idea as the one we did, I think a couple pages ago now at this point. I have y equals mx plus b form. Technically there is no plus b, but if there's nothing written there, it's like there's a plus 0. So that tells me, with my m being the number in front of x, it's a negative 1. I turn it into a fraction by putting it over a 1, so I'm going to rise down 1, and you always run right. And b, being that number that's not written there, is going to be 0. So I'm going to start at the origin when y is 0, and go down 1, right 1, down 1, right 1, down 1, right 1. When I run out of space for doing that, or when I hit the end of the graph, I want to do the complete opposite, which is going to be up 1, left 1, up 1, left 1, up 1, left 1. And you'll notice after you do that a couple times that you end up running into a point. You want to try and run into a point. I know there's a lot of points on this one because it's such a small slope, but at least do the plotting until you hit that point. Once you have that graph, you refer to your symbol. It's a greater than or equal to. That or equal to tells me that it's going to be a solid line, and since it's greater than, I'm going to shade it up. So I connect it with a regular old solid line, preferably as straight as you possibly can, and then shade it up. So shade towards the top of the graph. Everything from that line and above. So again, because this was a system, we are looking for where they share a solution. The last system that we solved, the answer was their intersection point. But remember what I said about being on a dashed line. If you're a point on a dashed line, as this intersection is, it's not a solution. You can't have a solution on a dashed line. The whole point of the dashed line means it doesn't have the or equal to, which means it's not included. Your solutions for this system of inequalities is going to be in the double shaded region over here. So part B says, is the point -4, 4 a solution? The answer to that is no, simply because of what I just said. It is not, or I'm sorry, it is on a dashed line. If they were both solid lines, it absolutely would be. If they were both dashed lines, it still wouldn't be. The fact that it's on a dashed line to begin with just means that it is not a solution. Okay, so all of my solutions are here in this little circled area that I have, a little bit here too. I didn't get the circle very well, but it also continues. Even though the grid ends, the graph doesn't end. So part C that says how many solutions are there to this system of inequalities is going to be infinite. There are infinite solutions. Possibilities are endless. Anywhere in that double shaded area. So then part D says the name one possible solution. You can pick any point in that double shaded area. I'm going to use this point right here, which is 8, 2. That is definitely not the only solution. Remember, there's infinitely many solutions. Pick any point within that double shaded region. All right, number 510 is relatively easy as long as you remember where solutions are on a parabola. We talked about how we can check solutions earlier. Your solutions to a parabola are just where it crosses the x-axis. So it crosses at x equals 1 and x equals 5. So you can write your answer like this, or we did briefly talk about this solution set notation. You can put the 1 and the 5 in that solution set. These are not both needed. You could do one notation or the other, but those are your answers. All right, moving on to 511. It says graph y equals negative 16x squared plus 112x, where y represents the height in feet above the ground and x represents the time in seconds since the rocket was fired. Because we're graphing a parabola, you have to use the y equals button on your calculator. So at this point, go to the y equals button on your calculator and type this function in exactly how you see it. Negative 16x squared plus 112x. Once you're done typing it in, you're going to look at the graph of it because you want to have an idea of what the graph looks like before you go ahead and start graphing it. What happens with this one, because the numbers are so big, is that you can't see it on your graph. Your graph as a 10 by 10 on your calculator is just too small. There is a zoom out option. If you hit the zoom on the top middle button of your calculator, you can keep zooming out until you can see the whole picture. But ultimately, what we always talk about you needing is the table. So you're going to want to hit second graph. Now, what's different about this one versus other parabolas that we've graphed is that it is a real world scenario. So we're talking about height and time. You can't have negative heights or negative times when you're talking about this situation. So even though the table on your calculator will go on forever and ever and show you all negative possibilities, you can only graph the positives. So I want you to kind of jump up and down on your calculator table and just see where your negatives start and where they end. So you should notice that anything above the 0.00 on your table has negative numbers on the y column and the x column for that matter. So those are unplottable, which means I'm going to start at 0, 0. Then you keep going down. The next point is 196. Then I have 2, 160. Those are all good points. 3, 192 is good. 4, 192 is also good. I keep going. 5 is 160. 6 is 96. And 7 is 0. After that, y ends up being negative, and those aren't plottable. So those are the only points I can plot from the table. I say only like it's not a lot, it's quite a bit, but it's going to help you figure out your axes. So hopefully you noticed that your axes are not labeled. So I see over here that my x-axis can be from 0 to 7. So I know 0 is right here. You don't want to try and fit 0 through 7 on this little itty bitty piece. You want to spread it out as much as you can. It's a big graph. So you can go every 4 boxes. You could do every 3 boxes. It really doesn't matter. Just try and spread it out a little bit for yourself. I promise long run it's going to be a lot easier for you to graph if you have these numbers spread out for yourself. Okay, so that's how you're going to do the scale for the x-axis. For the y-axis, you look at the biggest number. The biggest number that I see over here is 192, which means I'm going to want to graph that y-axis all the way up, scale that y-axis all the way up to at least 192. I could even stretch it to go up to 200. So you definitely can't count by ones. Like if I did 1, 2, 3, I would never ever make it to 192. I think your best bet is to count by 20s. There are definitely other options. 20 is just a nice, easy number to count by. And it'll definitely fit to get you up to that, 200 when we're counting by 20s. Okay, and remember that y is height, so this axis is my height. And this one down here is the time in seconds. and height was in feet. So then you just go ahead and plot your points. So 0, 0 is really easy. I know 7, 0 is going to end up being here. 196 is going to be about here. And we're not perfect. You just try and get it as close as you can. 160 should be perfect because 160 is part of the scale. Okay, 3 is 192, so it should be kind of close to 200. 4 is the same. Okay, 5 is 160. And 6 is 92 again, so those should match up. You know, parabola is, for this one, an upside down U. It should be curved at the top, so when you connect your points, do not make that a flat plateau on the top. It should go up a little bit, so it's a curve. Try to ignore the fact that that's a little sloppy. And there we have it. Okay, so a curve at the top for sure, just like that. So it goes a little higher than those 192 heights. Okay, so once you have that graph, we're going to move on to part B. It says, how many seconds does it take for the rocket to be at its highest height? This right here in between 3 and 4 is its highest height. It doesn't want to know the height, though. It wants to know how many seconds. So I'm going to go down here to my seconds axis. Remember, x is time, and it's halfway between 3 and 4. Well, halfway between 3 and 4 is going to be 3.5 seconds. All right, 512. Solve the following system of equations algebraically. So this one's a little bit different. When you're solving a system of equations algebraically, your goal for solving a system is to find x and to find y. If I were solving this graphically like I did previously in the review packet, I'd have to get both of them in y equals mx plus b form, graph them both on the grid, and see where they intersect. But if you're doing it algebraically, it's a little bit different. Your goal is to still get the x and y value that they would be intersecting at, but again, your method to solve it is different. So right now in both equations, I have an x and a y. You can't solve for x and y at the same time, so you have to eliminate one of them. You're going to use the elimination method. And it is going to be set up for you perfectly, just like it is for this one, for elimination to start working out for you. So there's a couple ways to do elimination. I'm going to show you the quick way, and then I'm going to show you the shortcut that, again, works every time. I really want to drill home those methods that work every single time. So if I was trying to cancel out x for this one, I have a 2x and a 4x. To cancel out a positive 4x, I would need this number right here to be a negative 4, because negative 4 and positive 4 would cancel each other out when they add the two equations together. Okay, so to get that 2 into a negative 4, I'd have to multiply the top equation by negative 2. That's one way of doing it that requires quite a bit of thinking. The way that a lot of people tend to prefer, because again, it works every time, is put parentheses around both of your equations, take this number, I'm sorry, I'm pointing at it, but you can't see me pointing. Take that 4 and bring it up here. Take this 2 and bring it down here. So I'm going to get rid of those lines just so it's less messy. Okay, we're just kind of flip-flopping those numbers. Now the reason for that is because when I distribute this 4 through to the 2x, I get 8x. When I distribute this 2 to the 4x, I get 8x. Now the problem when I go to add 8x and 8x together is they're not going to cancel because they're both positive. That would give me 16x. So what you also have to do is make one of them negative. It does not matter which one you make negative. It's entirely up to you. Now, what you do have to make sure you do is when you distribute through to everything, even the right side of the equation. So I'm going to distribute the top through first. 4 times 2x is 8x, and 4 times 3y is going to be a plus 12y, and 4 times 6 is going to get me 24. Okay. Then I distribute that negative 2 through on the bottom. Negative 2 times 4x is a negative 8x. Negative 2 times 2y is a negative 4y. And negative 2 times negative 4 is a positive 8. It's going to work out now. When I go to add these two equations together, the x's are eliminated, and I can very easily solve for y now. So I combine my y terms. 12y minus 4y is 8y. And then 24 plus 8 gets me 32. So to get y by itself, I just have to divide by that 8, and I get that y is 4, and that is half of my answer. Now, you don't have to go through that whole process again. Now to find x, you just pick whichever of these two equations is easier. I think the top one's a little bit easier. 2x plus 3y equals 6. And you take that y value and you just plug it in. We already know that y is 4, so I can go ahead and plug it in. So 2x plus 3 times 4 equals 6. And then I go through and I solve that for x. So the 2x stays, 3 times 4 is 12, and the equal 6 comes down. Okay. I get rid of what's being added or subtracted first, so I'm going to subtract 12 from both sides. The 2x and the equals comes down, and 6 minus 12 is a negative 6. To get rid of that 2, I divide, and I get x equals negative 3. So my overall answers are y equals 4 and x equals negative 3, and you can write it as an intersection point like you would otherwise see on a graph, negative 3, comma 4. All right, moving right along. So these ones are the step-by-steps where you really need your calculator to show all your work for this. So 513 says Emma is taking a road trip. She decided to keep track of how many gallons of gas she uses along the way. The results are shown in the table below. So this is going to be your x values and your y values. X is always on the left and y is going to be on the right. That makes this your list 1 and your list 2. So it says for part A, determine the equation of the line of best fit using linear regression for the following data. We haven't done linear regression in a while, but it's essentially mostly the same steps except for this one right here as exponential regression. So step 1 is to press the stat button and then press enter for edit. You're going to clear out your list by highlighting over L1, hitting clear enter, highlighting over L2, hitting clear enter. And then once those are all cleared out, you have a completely blank screen. You're going to type your x values into L1 and you're going to type your y values into L2. Okay, so take a second to do that. Pause the screen if you need to. I'm going to move on to the next step. So once you have all those numbers typed in, you're going to hit the stat button again, hit the right arrow to go over to calc, and then you're going to go down to choice 4, which is lin reg, or linear regression. And then you are going to press enter until you get your results to show up. So what you should be seeing on the screen is what I'm just going to go ahead and write up on here so you can check that you have the right screen. If you have the wrong numbers, you plugged a number wrong into your list. So go back and check that if you have the wrong numbers written down. So again, this is what should be on your calculator screen. You should have an R value as well, but we'll talk about that once we get to part B. So for part A, that's technically all the information you need to write your answer. We're at this point right now. Substitute values into equation form and round. It says to round in the directions to the nearest hundredth. So I'm going to round them first and then I'll substitute them in. So a to the nearest hundredth is 2 places after the decimal point, but you look at that third digit to see if it'll bump that up. 1 does not bump it up, so it's going to stay 0.05. For B, I also need 2 places after the decimal point. I look at that third digit, which is a 9. That 9 bumps that 1 up to a 2, so this is going to be negative 0.92. Now that I know what A and B are, I can plug them in for A and B in the format that the calculator gave for my final answer. So the y equals carries over, 0.05 gets plugged in for A, the x comes down, and then minus 0.92 comes down as well, and that is your final answer for part A. All right. B, what is the correlation coefficient? That's going to be the R value in the calculator. If it helps, it's correlation coefficient. That's always going to be R. You never use the R squared. Okay, just completely ignore it. It shouldn't be on there. It's kind of there to throw you. Just use R only. So R for this one, when I just copy it from the calculator, is 0.999,218,5774. If it told you to round, you would round, but this one doesn't, so just write out the whole thing. All right, now part C says, what does this correlation coefficient tell us about the relationship in the data? So the relationship in the data is all dependent on whether, first of all, it's positive or negative, and whether it's strong, moderate, or weak. So you have to answer those 2 things. It's a positive number, so it's very, very easy to tell that it is a positive correlation or a positive relationship. to tell if it's strong. The closer it is to 1, the stronger it is. 0.999 is very close to 1. So this is a strong positive relationship. Okay, so strong is close to 1 or -1. It would just be a negative strong relationship if it was -1. Weak is close to 0. And moderate is about a 0.5. Halfway between the two. All right, part D says, does this data and situation represent causation? Causation is kind of how it sounds. It's a cause and effect relationship. So you want to go back up to the situation. It's talking about miles driven and number of gallons used. So essentially, does one of those cause the other one to happen? Does the number of gallons used, or I'm sorry, does the number of miles driven have an impact on the number of gallons used, or does it affect it? Is there a cause and effect relationship there? The answer to this one is absolutely yes. Okay. And it does say to explain, so my explanation is going to be yes, because driving more miles causes, so driving more miles causes the number of gallons of gas used to change. The big word is causes. One thing causes the other. An example that we used in class that was not causation but did have a relationship was age and height. As you get older, generally your height increases as well, but it doesn't cause it to happen. You don't have a birthday and then grow a couple inches immediately. They don't have a cause and effect relationship. All right, last problem in the packet. Another regression equation. So I'm just going to kind of walk you through the steps real quick for this one because they're the same initial first steps. But this is going to be your L1. This is going to be your L2 because that's X. And this is Y. So part A says find an exponential equation that best represents the data above using exponential regression on your calculator. And then we're still rounding to the nearest hundredth. So the same first steps, you're going to go back to that step button, press enter for edit. Clear out your L1 and L2 the same way by highlighting over them and hitting clear enter. Type in your X values in L1 and your Y values in L2. If you need some time to do that, go ahead and pause. But step 4 is going to be to hit stat, scroll over to calc, and then go down to, instead of linear regression, hit exponential regression, choice 0. Once you do that, you should end up with this. So I'm going to write down what your calculator should say. And your equation looks a little different on your calculator, but it says a times b raised to the x. This is the nice way of writing that out. So a should have been 47 point blah, blah, blah. B should be 0.94, blah, blah, blah. Okay, so those are the numbers that you should have on your calculator screen. Again, if you don't have those on your calculator screen, it would be because you plugged in the numbers incorrectly from the table, or maybe you hit the wrong regression. Just go back and make sure you followed the steps and typed in the numbers correctly. So at this point, I'm going to round them, and then I'm going to, just like I did in the last one, substitute the values into the equation form. So to the nearest hundredth, which is 2 places after the decimal point, I look at the third digit after. That 9 does bump this up, so this will be 47.97. And then for the last one, I again need it to the nearest hundredth, so 2 places after, but I look at the third. That 4 does not bump that up, so it's going to stay 0.94. So now to get my final answer, I plug in A where I see an A in the format, and B where I see a B. So my final answer is Y equals, plug in A, 47.97, times plug in B, 0.94, and I leave raised to the X. This is your answer to part A. All right, now it's really important that you get part A right for this specific question because parts B and C start by saying use the equation from part A. So you really want to make sure that that is done correctly. So for B, it says use your equation from part A to predict the depth of water. That should say temperature of water. It's just a typo on my end. If you want to fix the typo while we're there on the next one, it should say temperature there as well. Okay, not a huge deal. All right, but again, use your equation from part A to predict the temperature of water after 48 hours have elapsed. Round your answer to the nearest tenth of a foot. So I'm using that equation from part A, and it's giving me a number here, 48. Now it says 48 hours, so I'm going to go back up to this table and look at where I see hours right here. Hours is X. So even though it doesn't directly tell me, it's indirectly telling me that X should be 48. And if I'm using that equation from part A, all I'm going to do is in place of X, plug in 48. And this will also help me. It says predict the temperature. Well, Y was the temperature. So it's asking me to find Y. I should leave Y alone and just plug this into my calculator. So plug it in exactly how you see it. And just double check that you get the number that I'm writing up here. Again, plug it in exactly how you see it, and that's what you should get. When I round that to the nearest tenth, that is 1 digit after the decimal point, but I have to look at that second digit to see if it'll bump that up. 6 does bump 4 up, so it's going to be 2.5, and we were talking about feet, so 2.5 feet after 48 hours. You kind of want to make sure that makes sense. If you look back at your table, the hour started at 2 and it was 44.7 degrees. Oh, it shouldn't be feet, it should be degrees. Oh my goodness. So this should be degrees Celsius. That's all about my typo. I apologize. It will not be like that on your final exam. It'll be consistent. But the 2.5 is the big part. As long as you got that number, you know what's going on and you have got this question down. Okay? So the nearest tenth of a degree, I should say, if you want to fix the typo. I apologize for that. So 2.5 degrees. We're talking about how that makes sense. Sorry, jumping back to that. We started at 2 hours, and the hours were going up as the table went on. And notice the temperature was decreasing as the table went on. So it does make sense to have a temperature of 2.5 degrees after that many hours of 48 have gone by. All right, last question. So use the equation from part A, same thing again, to estimate the time X. So in this one, we are finding X, that the temperature of the water was at exactly 30 degrees Celsius. So because it's giving me 30 degrees instead of hours, I need to go up here and see degrees is not X. I need to plug that in for Y because the temperature is a Y value. So 30 needs to get plugged in for Y in this equation from part A. So it starts off with Y equals. I'm going to start off with 30 equals. It'll be 47.97 times 0.94, and I'm going to leave the X there because, again, I'm trying to find X. Now, this one is a little bit more challenging than part B because of where X is. X is up in the exponent, which means you need to use logs to get that down. Now, like we said earlier in this review packet, in this video, you can't use logs until the number that's being raised to the X is by itself. So in order to get that by itself, you've got to get rid of that 47.97. And I know the decimals kind of throw people off, but it's the same method. Don't let it throw you. To get rid of that 47.97 that's being multiplied to the 0.94 to the X, I'm going to divide by 47.97 on both sides. So on the right side, that 47.97 will cancel. On the left side, unfortunately, 30 divided by 47.97 is not a nice number. You have to write out the whole decimal. You cannot round until your very last step. Okay, so that's the decimal that you should get, and then the 0.94 to the X just comes down. Now that we are at that step, we are all set to go because this is by itself. That 0.94 to the X is all alone over there. So we're good to start with log. So I'm going to write the log on both sides. Again, not rounding that decimal. Bring down the whole thing. And then I'm going to write the word log on this side of 0.94 to the x. Now, for sake of convenience for you and myself, the whole point in writing the word log was to take this x and bring it down in front. Nobody wants to write that out again, so I'm just going to put the x up in front and scribble it out there. You could write it in a second step if you want to, but ultimately that's what you're going to end up getting. Okay, so now that this business, that arrow, that everything is all gone, here's the equation that I have, and I'm trying to get that x by itself. The only thing that's standing in the way of the x being by itself is the fact that it's being multiplied by the log of 0.94. So to get rid of it, I am going to divide by the log of 0.94 on both sides. So the log of 0.94 cancels over here. You get x by itself, but you've got to plug that in to get your final answer. So again, be very careful, especially with plugging in that long decimal. Log of open parentheses, type in that whole thing, close the parentheses, then divide it by the log of 0.94, close your parentheses. I'm going to throw the decimal up here, so just practice plugging it in your calculator to make sure you got this down. This is what you should ultimately get as your decimal. Okay, so the directions say to round to the nearest tenth, just like the part B. Nearest tenth is one place after the decimal point, but I have to look at that second place to see if it'll bump it up. That 8 does bump the 5 up, so my final answer is 7.6 hours is how long it would take for the temperature to reach 30 degrees Celsius. And just a reminder, because I have this last page up here, these are the formulas that will be given to you the day you take your exam, so they don't need to be memorized. You just need to know when they apply and how to use them, but you don't need to waste your time memorizing them. They will be provided to you. Okay, best of luck studying to you guys. If you need anything else, all the information you need is posted on Blackboard, and you are more than welcome to email me at any point in time, gastonam@buffalostate.edu. Good luck.